Doing homework 1, problem 34. It's asking what are the intensities of sound waves with sound intensity levels 46 decibels and 103 decibels. So writing down our knowns, we know that the given sound intensity is 1 times 10 to negative 12 watts per meter squared, and that we have our bells is 46 decibels, so B1 and B2 is 103 decibels. So the formula that we know is going to be our bells equal to 10 decibels log base 10 intensity divided by I naught. So the variable that we're going to be solving for is the intensity. So we have to get this formula in terms of I. So we're going to have to do a log base change. And so we know that, for example, log base 10, in order to get this in different terms, we're going to end up with something that looks a little bit like this. So we're going to go ahead and do that to our equation, but first let's get the log equation by itself. So let's go ahead and divide both sides by this 10 decibels. So we end up with the bells divided by 10 decibels is equal to log base 10 I over I naught. Right, and now we're going to do the base change. We're going to end up with I is equal to I naught 10 to bells divided by 10 decibels. And that is going to be the equation that we are using. So first, so now that we have the equation, we know we have our known variables and we only have one unknown, we can go ahead and solve for the equation. Alright, so we're solving for I. Alright, so we'll do for part A, it's asking for the intensity for 46 decibels. So I is going to be equal to I naught, which is 1 times 10 to negative 12 watts per meter squared. And then times 10 to our bells, which is going to be 46 decibels, divided by 10 decibels. And we end up getting an answer of 3.98 times 10 to the negative 8 watts per meter squared for our first intensity. So we'll go ahead and put I1 for that one. And for part B, we are solving for 103 decibels. So same equation, I is equal to 1 times 10 to negative 12 watts per meter squared times 10 to the 103 decibels over 10 decibels. And so plugging that into the calculator, we once again for I2 is equal to about 20 times 10 to the negative 2. So it's pretty straightforward. We just rearranged this given formula that's also on our formula sheet and solved for I, and then plugged in the numbers we were provided. So these